Hello guys! Welcome back to Doc Gilmac online tutorial. Doc Gilmac Math TV Basic Trigonometry Tutorial. Are you ready for the next tutorial? So if you're ready guys, let's begin. The topic I will be discussing for today's tutorial is all about proving trigonometric identities. What is an identity or identical equation? An equation in which the two sides of the equality are equal for all defined values of the variables. Consider illustrative examples. Number 1. 3 times the quantity x plus 5. Applying distributive property in the left side of the equation, 3 times x is 3x plus 3 times 5 is 15. So as you can see here, the right side of the equation is simply the product of 3 and x plus 5 in the left side of the equation. Number 2, quantity x minus 5 squared. As you can see, we can simply apply a square of binomial in the left side of the equation. X minus 5 quantity squared is simply equal to x squared minus 10x plus 25. How do we prove trigonometric identities? In proving trigonometric identities, we need to show either left side of the equation is equal to the right side of the equation, or right side of the equation is equal to the left side of the equation. So take note of that. Consider illustrative examples. Prove the following trigonometric identities. Illustrative example number 1. Tangent x times cosine x is equal to sine x. As you can see here, the left side of the equation is more complicated than the right side of the equation. So we're going to show whether the left side of the equation is equal to the right side of the equation. Consider tangent x. Applying ratio identities, that is, we can rewrite tangent x as sine x over cosine x. Okay, multiplied by cosine x. Okay, so we're going to place a question mark here since we are not yet sure whether it is equal to the right side of the equation, which is sine x. Simplifying further, sine x over cosine x times cosine x, as you can see, we can cancel out cosine x. So from here, this is just equal to sine x, which is simply equal to the right side of the equation, which is sine x. So from here, we have proven that the left side of the equation is equal to the right side of the equation. So therefore, the given trigonometric equation is an identity. Consider illustrative example number 2. Tangent squared x minus sine squared x is equal to tangent squared x times sine squared x. As you can see here, the left side is again more complicated than the right side of the equation. We're going to show whether the left side of the equation is equal to the right side of the equation. So again, we're going to place a question mark here. Okay. Consider tangent squared x. Again, applying ratio identities, we can rewrite tangent squared x to be equal to sine squared x over cosine squared x. Minus sine squared x. Simplifying further, so from here, we can actually apply subtraction of two fractions. So we can rewrite this as sine squared x minus cosine squared x times sine squared x. So sine squared x times cosine squared x all over cosine squared x. Again, we're going to place here a question mark since we are not sure whether the left side is equal to the right side of the equation. Simplifying further, applying factoring, we can factor out sine squared x here. So we're going to write sine squared x multiplied by 1 minus cosine squared x. Applying factoring common monomial term all over cosine squared x. Again, we're going to place here a question mark. Consider sine squared x times 1 minus cosine squared x over cosine squared x. Actually, we can rewrite this as sine squared x all over cosine squared x. Times sine squared x. Since, take note, 1 minus cosine squared x is equal to sine squared x, applying Pythagorean identities. So again, we're going to place a question mark here since we are not yet sure whether this is equal to the right side of the equation. Moving on, we can actually simplify this sine squared x over cosine squared x to be tangent squared x, applying ratio identities times sine squared x. So as you can see, we have proven that the left side of the equation is simply equal to the right side of the equation, which is tangent squared x times sine squared x. So take note of that. Consider illustrative example number 3. Sin x over 1 plus cosine x is equal to 1 minus cosine x over sine x. As you can see here, guys, both sides are complicated. So we can choose any of the two sides to determine whether they are equal. So from here, I will be choosing the right side of the equation. 1 minus cosine x over sine x. The first thing we have to do here is to simply determine the conjugate of 1 minus cosine x. The conjugate of 1 minus cosine x is 1 plus cosine x. So that the equation remain unchanged for the right side of the equation, we multiply both numerator and denominator by the conjugate of 1 minus cosine x, which is 1 plus cosine x. So over 1 plus cosine x. Take note, 1 plus cosine x over 1 plus cosine x is just equal to 1. Now let's perform the operation multiplication for both numerator and denominator. So this is simply equal to 1 minus cosine squared x. The numerator is equal to 1 minus cosine squared x all over sine x times the quantity 1 plus cosine x. Okay. Simplifying further, we can actually rewrite 1 minus cosine squared x to be equal to sine squared x using Pythagorean identities. Okay, so sine squared x all over sine x times 1 plus cosine x. Okay, simplifying further, we can actually, take note, this is sine x. We can actually cancel sine x over sine x. As you can see here, if we're going to simplify further, this is just equal to sine x all over 1 plus cosine x. So from here, we have proven that the left side of the equation is simply equal to the right side of the equation. So take note of it. Okay guys, again, I would like to thank you for watching Doc Gilmac Math TV. Stand by for my next tutorial. Stay safe everyone, and may God bless us all.